All right, guys, we're going to start our next unit on exponential functions. So real quick, I just want to talk about what we do know. So we know that a linear function is written in mx plus b4. So we know that that's what the equations look like. Today, exponential, our new equation, is going to be written in a times b raised to the x. Okay, so our exponent is going to be what our variable is. Now let's take a look at what the graphs look like for these. And again, you can always type this into your y1 or your y equals button, and you can see determining on what kind of graph it is. Okay, so with this first one, when you read a graph from left to right, you go always from the left up to the right, you're going to notice that both of these graphs are going up really, really, really fast. Not going up consistently, like a linear function, like a straight line, but they have a little bit of a curve to it. This is an example of exponential growth. And again, growth meaning that our graphs are going up at a rapid pace. Now, if I look at these two examples down here, okay, again, here are the equations that you're going to notice are written in that new form, a b to the x. So if you look at both of these, both my graphs are going down really, really fast. So we call these graphs exponential decay. And again, decay meaning it's going down, it's decreasing. So help you remember, decreasing, decay. Okay, easy peasy so far. Now what I'd like to do is we are going to talk about the parts to an exponential function, okay? So again, remind yourself that this is our new way of writing this equation, a b to the x. So you notice whether it's growth or whether it's decay, it's going to be written in the same form. The only thing that's going to change are what these are called. So if I look at the number in the front of each one of my parentheses, this will always be your initial value or your y-intercept. Same thing with the decay function. The number in front will always be your initial value or your y-intercept on the graph. Okay. So this is going to be the important part. If the number inside the parentheses, if it is bigger than 1, this will always represent an exponential growth. Okay? If my b value, so the number inside the parentheses, is between 0 and 1, okay, that means this will represent an exponential decay. Now, the b value, the number inside the parentheses, actually has a name. So we will either call that the growth factor, okay, meaning how much it's growing by, or we could call it the decay factor if it happens to be a decay function. Now, a lot of these questions are going to deal more with scientific type examples. So when we talk about how much substance is growing or decaying, we usually want to use like a percentage, whether that chemical compound is growing at a rate of 20% or maybe it's decreasing by a rate of 50%. So in order to figure out the percent that it's growing by or decreasing by, what you're going to do, so this is going to be probably the hardest part about today's lesson, are these two things here. You're going to take your b value and you're going to subtract 1 and you're going to get an answer. You're going to take that answer, multiply it by 100, and that's what gives you the percent. Okay? To find the decay rate, what you're going to do is you're going to do 1 minus your b, get an answer, multiply it by 100 because percent's out of 100, and then that'll be your answer as a percent. Okay. If I were you today, this is probably going to be the most important information. You might want to take a picture of it, kind of as if we were doing vocab cards in class. This would be on your vocab card. So let's look at some more examples. These are going to be examples that kind of your classwork is going to look like. Okay. All right. So if I look at this first example, I'm going to write over the top a b to the x. Okay. So my initial value is always whatever the a value is, or the number in front. So my initial value is a, or the number in front of the parentheses would be 3. Now my factor is my b value, the number inside the parentheses. So in this case, my b value is 1.8. Now because that is bigger than 1, think of it, $1.80. That's bigger than $1. This represents an exponential growth function. To find the percent rate, again, I need my answer to be as a percent. I'm going to take my b value. So I'm going to take my 1.8 and I'm going to subtract 1 from it. So use your calculator, which means I get 0.8. Now what you need to do is I have to multiply that by 100. So my answer would be 80%. So it's growing at a rate of 80% in that situation. So what I'm going to have you do right now is, why don't you pause the video and try this example right here on your own. See if you can fill in the information, and then play the video again and see if you get your answers correct. All right, so for this one, I'm going to do the same thing. A times b raised to the x. So my initial value, again, is the number in the front. So that happens to be 2.1. My factor, that is the number inside the parentheses. So that one is 0.8. So because 0.8 is a number between 0 and 1, think about it. What is between no money and $1? Well, 80 cents. This represents exponential decay. So in this case, to find your percent rate, this one is different than the last example. So I have to take 1 and subtract the 0.8. The whole problem with this is you should never, ever, ever have a negative percent. Okay, so my answer becomes 0.2. Again, I'm trying to find a percent, so I got to multiply that by 100. So the answer for this one is a 20% decay. All right. Pause the video again and see if you can answer the example down here as a word problem. All right, so Haley's starting salary for her new marketing management job is $32,000. She calculates her projected salary for the next 5 years using the function y equals a times b raised to the x. Little typo there, that x should be up here as an exponent. So I want to know exponential growth or exponential decay. So in order to determine that, you got to look at the number inside the parentheses. 1.12. Is that bigger than 1? Well, yeah, it's 0.12 over 1, so that means that's growth. So my initial value means, what did she start out at? Well, she's starting out at $32,000. So that's my A value again. My factor. Remember, your factor is the number inside the parentheses, which is 1.12. So to find the percent rate, because it's bigger than 1, I'm going to take this answer and I'm going to subtract 1 from it. It means I'm left with 0.2. So now what I need to do, need to multiply that by 100. So her salary is increasing at 12% each year for the next 5 years. Okay. Guys, if you have any questions regarding these notes, please, please, please email me or email Mr. Hart. We can do a video conference call to go over these. We can email, Google Chats, whatever you need. We're here for you. Have a great day.